So welcome to our discussion as we conclude section A. This is our last question in section A from the paper that I've actually been revising. It says in a nuclear reaction, uranium nucleus was bombarded by a slow-moving neutron. On disintegration, two daughter nuclei of barium-38 and krypton, with atomic number 56 and 36 respectively. Write the nuclear equation for this reaction. So they told us in this case that it was uranium. It was actually uranium that disintegrated in this case. So they told us it's a uranium nucleus. So now uranium nucleus there, they have told us, so that would be 235 and that would be 92. It was bombarded by a slow moving, it was actually bombarded by a slow moving neutron. That's the symbol for a slow move for a neutron. Then it produced barium. They have told you barium 138 plus, in this case, krypton 95. So here we are supposed to have 95 with atomic number 56 and 36. Yeah, so that's what they told us. So you need to actually balance up this or equation that they have actually given us. So the number of atoms on the left hand side should be equal to what you're going to have on the right hand side. So remember, some more neutrons are actually produced. So when you add, in this case, when you add 138 plus 95, what is that going to giving you? It's giving you 233. So if you notice 235 plus 1, that's 236 on the left hand side. So how many are remaining to make 236 from there? So minus 236, so 3 are remaining. So you are supposed to put up 3 neutrons were actually produced. And this is basically the nuclear equation for this reaction that they wanted you to write. Okay. B says, explain how energy is produced during a nuclear fission reaction. Remember, there are two types of nuclear reaction. There's nuclear fusion and nuclear fission, so don't confuse them. So how is energy produced? That's the question. So you could have said small amounts of mass is converted into energy during fission reaction. And this is in line with what Albert Einstein says: energy is equal to mass speed of light and mass times the square of the speed of light. So energy, the mass can be converted into energy and vice versa. So that's what we mean there. So small amount of mass is simply converted into energy, because this whole reaction, if you wanted, you could have said produces a lot of energy, and that energy is in form of gamma rays. So that is what you could have talked about. Give a reason why a moderator is used in nuclear fusion reactors. So usually there are things that we use like moderators, which we use. For example, moderators include things like graphite. Sometimes you can even use a water, in this case hard water, so you can actually use that to slow down. So moderators are simply used to slow down the fast moving neutron, so that it is able to split up the heavy nuclei. So we can simply say to slow down fast moving, or we can just say to slow down fast neutrons so that they can split the heavy nuclei. Or you could have said further, or cause, maybe let me say, or cause further fission reactions more effectively. Yeah, so more effectively. So the way it is that when more neutrons are produced, these are going to again collide with other atoms, so it will create a chain water, a chain reaction, such that energy will always be produced. So this is what you needed to do. Please, if you love what we do, subscribe to our channel, and you can actually share. Thank you so much. Learning with Mr. Nyendwa, we appreciate so much learning with us. You can look out for other series in chemistry, biology, mathematics, addition mathematics, and try to see what you can actually learn. Thank you so much for watching.